So today what we're going to be doing is we're going to be dividing radicals. So we've added, subtracted, and multiplied these radicals, so now we're going to learn how to divide them. So there's two steps when dividing radicals. So the first thing we're going to do is what's known as rationalize the denominator. So I'm going to put rationalize the dem. Now what that means is whenever you have a square root in the bottom, what you're going to do is you're going to multiply by that square root on the top and the bottom. And that's hopefully going to get rid of our square root in the denominator. The second thing we're going to do is we're going to then just simplify and make sure that it's as simple as we can make it. Okay, so the key step today is going to be this first step of rationalizing the denominator. So let's say I had the square root of 2 down here. So I have the square root of 2. What I'm going to do to both the top and the bottom to divide these radicals is I'm going to multiply by the square root of 2 over the square root of 2. Okay, so let's look at an example. Here I happen to have 8 over the square root of 2. So what I'm going to do is I'm going to multiply the top and the bottom by the square root of 2 over the square root of 2. So on top, 8 times root 2 just stays 8 root 2, and then in our denominator. Now this will always happen with the squares in your denominators when you rationalize this. The square root of 2 times the square root of 2 gives us the square root of 4, so I'm going to write that really small right here. Square root of 4, but remember we know that that's always going to just be the number that's inside, or 2. So there, we've rationalized our denominator. Now we're just going to simplify. So let's see, what is 8 divided by 2? Well, 8 divided by 2 just gives us 4. So know that this is the same thing as 4 root 2. Now when we divide radicals, what we're trying to do is we're trying to get rid of the radical in the denominator. So when your final answer should have no rads in the denominator. And every single time, if you have a radical in your denominator, you probably did something wrong. Okay? So here we multiplied by root 2 over root 2 and then simplified. Let's look at another example. So here we have 5 over 2 root 13. Now in the other example we didn't have a coefficient in front of our radical, but we're going to do the same exact thing we did before. We're still going to just multiply by root 13 over root 13. We don't multiply by the coefficient, just by our radicals. So 5 times root 13 is 5 root 13 over 2 root 13 times 2 root 13. What that's going to become is 2 times 13. Because here our root 13s, when I multiply those two by each other, it becomes just 13, and then we're just left with our 2 times 13. So let's just simplify this bad boy. We'll get 5 root 13 over 26. We do our 2 times the 13. I don't think that simplifies anymore, so that's our final answer. And notice, in our denominator, we have no more radicals. It's now a whole number, or it's now a rational number rather than an irrational number. Again, let's look at this one. So I have root 6 over 4 root 2. So I'm going to multiply by what? You're right, I'm going to multiply by 4 root 2 as you hear the train going by in the background. Then we'll get root 12 over 4 times, and those root 2's cancel each other out, 4 times 2, which then becomes root 12 over 8. Now, this one we can simplify even more, because this root 12 right here, we can make that's the same thing as the square root of 4 times the square root of 3 over 8, and we know the square root of 4 is just 2, so 2 root 3 over 8. Now as I'm doing that, remember I'm just simplifying my root 12. So here I have root 12, I'm now simplifying it to 4 root 3, or root 4 times root 3, and then I know the square root of 4 is the same thing as 2. So that's how I got 2 root 3 from root 12. And now that can simplify because I know 2 divided by 8 is the same thing as 1 divided by 4, or root 3 over 4, because I can divide both my 2 by 2 and my 8 by 2 to give me 1 root 3 over 4. And there's that imaginary 1 there if you want, or that invisible 1 there if you want to write it. So there would be my answer, root 3 over 4. Okay, so not every single radical is going to simplify like that. Here I knew that my root 12 right here was going to simplify, so I wanted to simplify that to make sure that I could simplify my entire fraction a little bit more. This is a fine answer, but this is the exact most precise answer that you can get. So let's look at one more. Now this one, we have a binomial, meaning we have a two-termed expression in our numerator, and we have just our normal, or not our normal, we have a radical expression in our denominator. So what I'm going to do is I'm going to do the same thing. I'm going to multiply by root 3 on the top and bottom. But up here, what I'm going to make sure I do, I'm going to make sure that I distribute that root 3 to both terms. So what I'm going to get on top, root 3 times root 3, remember that just gives me 3 plus root 3 times 5 root 2. So I'm going to just multiply my radical parts of that, and I'll get 5 root 6 over 7 times 3. And simplifying that just a little bit more, I get 3 plus 5 root 6 over 21. And looking there, I don't see anything that a 3, 5, and 21 have in common. So that's going to be my final answer right there of 3 plus 5 root 6 over 21. Okay, so now hopefully you have now learned how to divide radicals, which really is more just rationalizing the denominator and then simplifying. So remember that you have those two steps that you're going to do every single time. Okay?